Have you ever stopped to think about what it would take for an AI to not just see the world, but to actually get it? To have a real conversation with you about what it's looking at? We're not just talking about identifying a cat in a photo. We're talking about getting the joke, understanding the context, and actually reasoning about what it sees. Well, today we're going to dive into a project that's teaching AI to do exactly that.
All right, take a look at this. It's a classic internet meme, right? The text sets you up to expect this majestic, awe-inspiring picture of Earth from space, and then, bam, a world map made of chicken nuggets. We get the joke in a split second. But could an AI? Could it possibly understand the setup, the punchline, and just the sheer absurdity that makes this funny? Stick around because we are definitely going to find out.
You know, to understand a joke like that, an AI has to be more than just a master of words. For a while now, we've had large language models, like ChatGPT, that are absolutely incredible with text. They can write code, they can summarize articles, you name it. But that's all happened inside this text-only universe. The next big frontier, the real challenge, is connecting that powerful language brain to an AI eye and teaching it to discuss the visual world just like we do. So here's the crucial difference. A language AI is a whiz at text commands, but a truly multimodal AI, that's a whole different ballgame. It needs to be able to look at an image and follow a specific instruction about it. Not just, what is this, but a much harder question, like, what's unusual about this picture? Or, can you explain the humor in this meme to me? That kind of thing requires a fundamentally different and deeper kind of intelligence.
Okay, so how do you even begin to teach an AI to do this? Well, like with all AI, you need data, a ton of it. And this, right here, was the single biggest bottleneck that the researchers behind this project faced. There just wasn't enough of the right kind of data out there to train an AI for this super sophisticated task.
What they needed was something very specific, what's called visual instruction following data. Now, this isn't just an image with a simple tag like car or dog, no way. This is an image paired with a whole rich conversation about it. Questions, answers, detailed reasoning. Just imagine trying to create that stuff manually from millions of images. It would be insanely expensive and take forever.
So, faced with this kind of data desert, the researchers came up with a truly brilliant idea. What if you could use an AI that only understands language to create the exact visual training data you need? It sounds like a total paradox, right? Using an AI that can't see to generate data for an AI that can.
Here's how this incredibly clever process worked. They started with images that already had some basic text info, like captions and something called bounding boxes, which are just digital outlines of where objects are. They took all of that visual information and converted it into a pure text description. Then, they fed this text to GPT-4 and gave it a prompt, something like, "You are a helpful visual assistant. Now, create a detailed conversation about this scene." And boom! Just like that, GPT-4 started spitting out the exact kind of rich, conversational data they needed, all without ever actually seeing the image itself. So with this absolute treasure trove of freshly generated data, they were finally ready to build their model. And they called it LLaVA, which stands for Large Language and Vision Assistant. This is where it all comes together. This is where the AI eye finally meets the AI brain.
The way they built it is actually pretty elegant and simple. On one side, you have a pre-trained AI eye, in this case, a model called Clip, which is already an expert at recognizing stuff in images. On the other side, you have an eloquent AI brain, an open-source language model called Vicuna, which is great at conversation. The real magic, the secret sauce, is the translator that sits in the middle. It's a small but crucial piece that learns how to turn the visual info from the eye into a language the brain can actually understand.
Of course, the big question is, did it actually work? Does this clever data generation trick and elegant design actually result in a smart, visually aware AI? Well, it was time to put LLaVA to the test.
They started by showing it some pretty unusual images, like this one. Just take a second to look at it. We've got a guy with an ironing board on the back of a yellow SUV in what looks like a city street. It's strange, to say the least.
And the researchers didn't just ask, what is in this image? They asked a much harder question, one that requires reasoning and a real understanding of how the world works. They asked, what is unusual about this image? And the results were so telling. Other leading models, they really missed the point. One gave a flat-out wrong description. Another one was also incorrect.
But look at LLaVA's response. It not only correctly identifies what's happening, a man ironing on the back of a van, but it explains why it's unusual, saying it's not a typical place to perform this activity. It understood the context.
Okay, so what about our initial challenge, the chicken nugget world map? Can LLaVA go beyond just reasoning about weird activities and actually understand humor?
So here it is, LLaVA's answer. And honestly, it's incredible. It says the humor comes from the unexpected juxtaposition of the text and the image. It explains how the text builds up an expectation for something majestic, and then the picture subverts it with something mundane and silly. It didn't just see chicken nuggets, it saw the joke. It actually understood the meme.
And this wasn't just some lucky guess. When they tested it on a really tough academic benchmark called Science QA, the combination of LLaVA and GPT-4 achieved a new state-of-the-art accuracy of over 92%. So this demonstrates real, measurable, groundbreaking progress.
This is a massive leap forward, there's no doubt about it. But like any new piece of technology, it's super important to understand not just its amazing promise, but also its current limitations.
So it's not perfect. LLaVA can still stumble on really fine-grained details. It might not be able to read a tiny brand name on a yogurt container in a crowded fridge, for example. Or it might not recognize a specific restaurant like Ichiran Ramen just from the design of its bowl. The paper also points out this fascinating mistake. When it saw a fridge with yogurt next to some strawberries, it incorrectly assumed it was looking at strawberry-flavored yogurt. It's a subtle difference, but it shows us what the next big challenges are in achieving deep understanding.
LLaVA's incredibly clever approach to creating data has really kicked open a new door in AI. It's this powerful reminder that sometimes the biggest, most creative solutions are just about finding new ways to use the tools we already have. And it leaves us with this huge, fascinating question. What happens when an AI can not only see our world, but truly understand the context, the humor, and all the nuance within it? The conversation is just beginning.